I'm just gonna record this part here and I'm gonna write it down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So with the Siva of Eratosthenes, right? And he lived a long time ago. Sorry, I guess you can't write numbers and count and speak at the same time. Sorry about that. I wrote 27 terribly here. Okay, so what he did was he showed us, let me do 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Let's actually go to 50, 41, 42. So what I want you to do is you're actually going to write yours to 100. I'm only going to go to 50. But what this does is it basically shows you one way to find prime numbers. Now, one thing I want you to know about Eratosthenes is he lived in a time in history in ancient Greece where people would basically, like we started hearing a lot of the names of the mathematicians, like Eratosthenes, Pythagoras, Euclid, Aristotle, Plato, all those names. We start hearing that more and more. And so the way it works is 1 is actually not prime and it's not a composite number. So I'm going to just leave it by itself, okay? We're just going to write 1 and we're just going to put an asterisk. It's special, okay? Now, 2 is a prime number. So what you need to do now is you need to cancel everything that is a multiple of 2. So if these numbers that I'm canceling are multiples of 2, that means none of them are prime numbers, okay? So the activity is going to show you how to find the prime numbers below the number 50. And then I'm going to show you the divisibility rules briefly for how to break numbers down. Okay, so sorry, this one is a lot because it's 2. Now let's go to 3. 3 is a prime number, so we need to cancel everything, right? Let me see if it'll let me. We need to cancel everything. Let's see, let's use another one. Everything that is a multiple of 3. Now, some of them I've already canceled before, but I'm just kind of showing you, oops, sorry, that one was not supposed to be there. So we'll leave that as, okay, we're going to rewrite that 20, okay. So this is going to be 20. Okay. And then we're going to cancel that one. But you guys get the gist, right? You cancel the multiples of 3, and I'll let you finish up the ones for 3. Well, let's just finish it up. It's not that much. But you have the ones for 3 that are gone. 39, 42, 45, and 48. Okay, now we go to the next number. We ask, what about 5? Well, 5 is also a prime. That means that all the multiples of 5, which we've already canceled, some of these, and then we have 5, we have this, and this. So 5, 10, 15, 20, 25, 30. Okay, you guys get the gist. We've canceled the multiples of 5. That means for the prime numbers, 2 is prime, 3 is prime, 5 is prime, okay? What about 7? 7 is also prime. Perfect, so it goes there too. And then we cancel all the multiples of 7. Okay? Most of them are already gone. What is the next prime number? 2, 3, 5, 7. We keep going and we see it's 11 and then 13. Now, these two are called twin primes. Okay? And I'll come back to why that's interesting. Because we see 17 and 19 and they are called twin primes. Okay, so we see twin primes there and twin primes there. And then 23 is prime, and 29 is prime, and 31 is prime. Oh, twin primes. 31 and 29, twin primes, right? And then we have 37 is prime, and 41 and 43, twin primes. They're prime. 49 is prime. Now, if you cancel the multiples of 7, it's going to be 7, and then 14, and 21, 28, 35, 42, and 49, which is here. What I've just done is I've shown you the first set of prime numbers, and then you can use that information. Let's see, 31, and then 37, 41, 43, and 47. So everybody can see how we use the sieve of Eratosthenes. Now I want you to extend from 51 to 100, and that will allow you to actually say what are all the prime numbers underneath 1 to 100. So I'm going to stop, and then we'll discuss this more in detail.